So our webinar here today is a great illustration of the collaborative work that we do with the Great Bay Reserve. One of the habitats we think a lot about is salt marshes, in part because these systems are so vulnerable to the impacts of rising seas as well as coastal development. And we know that any sort of intervention that you might propose or envision for protecting salt marsh systems is going to require really good data, really good, robust, locally relevant data about land elevation, about the plant communities, and about the tidal regimes at a particular location. And that's really what the essence is of today's presentation. We've got two fantastic speakers. If you don't mind going back to the prior slide, Rachel. We have two fantastic speakers today that I'll just briefly introduce and then turn it over to them. Rachel Stevens is a wildlife ecologist with the Great Bay Reserve, and she's got special expertise in spatial planning and the development of geospatial tools. And as stewardship coordinator for the Great Bay Reserve, Rachel oversees the management and stewardship of the 10,000 plus acres of land and water that we protect. And she also works closely with land management partners to share habitat management tools and coordinate stewardship activities. And our second presenter is David Burdick. He's an associate research professor and the director of the Jackson Estuarine Lab at the University of New Hampshire, located just on the other side of Great Bay from where I am. And he's a broadly trained ecologist that works in salt marshes as well as dunes and eelgrass systems. In addition to being a researcher, he's also works on a lot of shoreline restoration projects, which means he's a great person to talk about the potential applications of the study that Rachel is going to be sharing today. So switch to the agenda. I'll just briefly tell you the kind of the flow of today's webinar. David's going to start with a few comments to kind of frame the presentation. Rachel will be digging in and doing the bulk of the presentation about a study she just recently wrapped up. We'll pause briefly kind of in the middle to see if there's any questions about the results and the methods. And then both Rachel and David will share some comments about how they see this work being applied within the management and restoration realm. And then we'll open it up for discussion, whatever time we have at the end. And we welcome both questions as well as comments during that time. And if we do find ourselves with a lot of interest and short on time, Rachel and David graciously agreed to stay on for maybe an extra 15 minutes at the end for a little more informal Q&A for those that might want to do that. But we will adjourn at noon promptly. And you're welcome, as I said, to put questions in the chat throughout as they occur to you, but we'll just take them at those two different times, once at midpoint and then once at the end. So with that, I'm going to turn it over to David.
Thanks, Lynn. And if Rachel could advance the slides, that'd be great. I'm just going to give you a little basic rationale for why salt marshes are important and why we want to keep working on them and why we need this information that's in Rachel's report. We know that these systems, by growing these fabulous plants at the water's edge, they provide habitat and support food webs. They're very productive. And they're productive up through secondary food webs, the secondary production of invertebrates and fishes. And they support biodiversity because they support endemic species like sharp-tailed sparrow, as well as plants that only grow in this area. They're great filters and they do a lot of neat things and service in many ways. Recently, they're recognized as storing carbon for the long term, but perhaps the most valuable thing in terms of a social value for us is that they protect lands from erosion, coastal erosion. And so that's going to loom large for us and the people who are working in these systems, recognizing and protecting that function and value of salt marshes that protect coasts. Next slide. Probably a lot of you have seen this slide, as well as the previous one, or just know the information that salt marshes build with sea level. So as sea level rises, the salt marshes build in elevation. And their elevation is they're poised systems. So it's a balance of building processes, so the plant growth, production of below ground biomass, which is approximately 5 times what you see above ground. So whatever you see above ground in a salt marsh, you multiply it by 5 for the below ground contribution. So it's a huge contribution. Most of it gets respired, but some of it doesn't. And as sea level rises, that portion that doesn't get responded is saved as peat and saved as reduced carbon. So it's a blue carbon source. And then of course we have eroding processes, just compaction, decomposition of the organic matter, and physical exposure. But now we're seeing much higher rates of sea level rise. And I have the next slide shows these rates from 1912, I believe, all the way up to the middle of the last decade. And you can see that sea level, these are monthly sea level averages. And so you can see they change a lot from month to month. And it really determines if there's storms during a period or if there's a couple of years with very little storm activity. And laid over that is the 19-year Metonic Cycle, where the sun and the moon line up to cause slightly bigger tides. The major point here is this long, slow increase in tides really has accelerated in the past 30 years. And so over the course of the last century, we can estimate it's about 2 millimeters of sea level rise a year. Now it's probably over 4 or 5 or maybe even 6 millimeters a year, depending on where you live in New England. And so the sea level rise has really gone up sharply. The question is, can salt marshes build that fast? And the answer is, from what we see, maybe not. In most cases, salt marshes can't quite build that fast. And so we have to make some decisions on how we're going to manage these marshes in the future. And it brings us to some important questions. Next slide. So what do we, these problems I just alluded to include agricultural legacies. On the left-hand picture, you can see a pretty straight line. That's an old agricultural berm, and these were all of the salt marshes in New England were terraced systems with terraced agriculture and berms or embankments and drainage features of ditches. And they're, with sea level rise coming up faster, they're causing big problems because areas are getting flooded, the plants are dying, and that causes the peat to decompose. Remember, there's not much biomass going in when the plants die. And so it creates big giant pools. So in a lot of our salt marshes, we are refocusing on trying to figure out how to repair hydrology in these systems. We're also getting a lot of eroding shorelines on our fringing marshes. In the middle picture, you can see a tree stump that was not moved. That's in situ, as we say, with a seaside goldenrod growing at the top, the base of the stump. So it's well within the tidal zone now, and the edge eroded and the sea level is rising, and we have problems where this was a healthy salt marsh 30 years ago. Now we can see there's no marsh at all in some spots and patches elsewhere. So thinking about creating living shorelines so we can sort of protect the shoreline using maybe some structural components as well as biological components of salt marshes would be great. And the last slide over is because marshes may be unable to keep pace with sea level rise, the last slide over shows Wagon Hill Farm, and the photograph is taken right down the line of where the rest of these trees that you saw in the middle photograph were growing, and those trees were removed and the shoreline was flattened to enhance migration at this site. So we have to think about enhancing migration. So we think about all these things. We really need to know the elevation ranges of the marsh plants and their habitats. So I'm going to hand this right over to Rachel.
Thanks so much, Dave. So really just going to do a very quick overview of this, the information that's in this report that we sent out when you registered, and it's available for download at this web address. The first thing I wanted to do is just give a big, giant shout out to the co-authors on this report. Jamie of NOAA's Office of Coastal Management was pivotal behind most of the data was incorporated in this. Chris Peter helped with field work and did the statistical analysis for this report as well. So thanks. For recording and the goal of what we're trying to overview today and of what we were trying to do is look at in detail tidal wetland vegetation elevation and ecotone boundaries in Great Bay. And our interest in elevation is because that's the primary determinant of the duration of tidal inundation, and that broadly affects the plant species assemblage. So the amount of tidal inundation really determines ecotones. Ecotone is the interface of two biological communities. And then in a marsh system, within those ecotones, it's things like plant competition that really affects vegetated species assemblage distribution. So in this diagram, we're trying to summarize that the only marsh plant that can tolerate flooding twice a day, so it grows closest to the water and forms the low marsh, is cordgrass or Spartina alterniflora. And then as you go upland towards the upland, so Spartina alterniflora can actually grow in less saline areas, but it's outcompeted by these other species. So we hope that the data that we provide will be supportive of this type of study that Dave just overviewed. So restorations, living shorelines, and adaptation projects specifically facilitated marsh migration. And we could put this information together because we're fortunate to have a couple of really high resolution data sets. One is this high resolution land cover statewide for tidal wetlands. And this photograph just sums it up to me. You can see in the bottom left, there's a brown dot that the arrow is coming from, and this shows the pan you can see in the photograph, which shows it mud flat because imagery was done at low tide. But even more surprising to me is you can actually pick out the narrow band of short form alterniflora that's surrounding that pan. This data set was done by the partners whose logos show in the bottom right-hand corner, but the maps were actually produced and the heavy lift for this project was done by our colleagues at NOAA's Office for Coastal Management. They were also behind the second data set that allowed us to put this report together that looked at high resolution LiDAR, so elevation data. And elevation can sometimes reveal things that the eyes can't see. Today, we're talking about the subtleties of elevational differences within a salt marsh, but this is the actual LiDAR data that was provided. And you can, the aerial photograph in the bottom left-hand corner in the box, I can't actually see the Osprey platform that's on the telephone pole, but it is picked out in the elevational data. So the land cover habitat data was done statewide, but the LiDAR elevation data was just done at 4 sites around Great Bay. It's where our 3 sites where we have biomonitoring, vegetative monitoring of salt marsh plants, so field assessment, and then at another 4th site where we were interested in potentially putting an adaptation project. The last piece of the puzzle that allowed us to put this report together is that we've been expanding our vertical control infrastructure. Control points tend to be associated with built infrastructure, so we've been working to put it in closer to marshes so we can get this really detailed elevational information. And that's being done as part of a nationwide study or protocol that's done at all 30 reserves that looks at coastal habitat response to changing water levels. So our land cover data, we did a field accuracy assessment and it actually comes out at 92% accuracy, which is really impressive. And then our LiDAR data is really information rich as well. It was collected in the form of 1/2 meter resolution bare earth digital elevation model. So each of these tiles, the contract for the LiDAR actually asks to have a minimum of 8 LiDAR point returns for each of these 1/2 meter tiles. But what we actually got was over 400 points per tile. So these bare earth elevation models are really super accurate. And this is just an example of one of the sites with a zoom in on a plowed field, and you can actually see the furrows of the plow on that. And so our data set for the LiDAR is over 1 million of these 1/2 meter tiles. And so all of that massive data gets boiled down into this simple graph. And so what this shows is the mean or median value for the elevation of each of the habitat categories shown along the bottom row. And then what's the gray bars are the 10th and 90th quantile values. And we chose these so what we could indicate is a conservative growing window. If we looked at the maximum and the minimum elevation ranges, we would show all the areas, elevational areas that plants could, for each of these habitat categories could possibly exist, but might not be growing at their maximum potential. So this is what this shows. And just diving in very simply, obviously our low marsh, just looking at the vegetated categories, our low marsh is obviously lower, but it has the largest growing window associated with it. And anybody that's walked around in a marsh, this makes a lot of sense. It's full of crevasses and there's lots of elevational variation associated there. In the high marsh, the 4 habitat categories that compose the high marsh, there's just 0.11 meters or 4.3 inches between the average values of them. And so this next slide to me is the real key of this whole talk and everything that we've been putting together to get to this conversation is that the growing window for the high marsh habitat categories is just 0.52 meters or 1.7 feet. So that really highlights to me why this habitat, the high marsh in particular, is so vulnerable. A little bit of sea level rise that's going on, as Dave illustrated, can really affect these marshes, and it needs a lot of sediment and movement within them, building of that peat for them to keep up with sea level rise. Pans and pools are also features of the high marsh, but obviously are depressions within the high marsh. And it shows here that pools are deeper than pans, which makes sense because that's one of the definitions. Pools tend not to dry out, so can support fish species and diagnostically rupea species. If I go back to the high marsh, it also makes sense if you look at the short form alterniflora, that's the lowest habitat in those 4 categories. And that's because it grows fringing around the pans and the pools along tidal creeks, which are obviously depressions. And then as we get up into our brackish, including frag and then terrestrial border, so Iva and Solidago, we're reaching higher elevations, which makes sense and is shown graphically in this image, where we generally run from the water's edge and up to the higher terrestrial border. And we've simplified this diagram to show just high marsh, but it's actually composed of these 4 different habitat types. We can then, so these are the ones that are included in the statewide land cover data set that we have for tidal wetlands. We can then simplify these habitat categories and roll them up to look for ecotone boundaries and the associated tidal datums with those ecotone boundaries. They're really distinctive within a marsh system because, as I said right at the beginning, the boundaries really are associated with the duration of tidal inundation. So at our highest astronomical tide, that's the interface between our upland and our marsh. We can find the mean high water mark at the interface between high and low marsh. Our marsh meets the mudflat at mean tide level, and mudflat turns into subtidal habitats at mean low water. So what's really cool is we had a tide station loaned to us from NOAA as part of our build out of our Sentinel site program here. And it was deployed during 2 seasons. And so this is a completely different way of looking at tidal datums and measuring tidal datums within Great Bay. But the 2 data sets broadly agree. And all the tide information is got into in a lot more detail in this report by Chris Peter, which is available for download at this web address on in the last bullet here. So this is overlaying the 2 data sets. As I say, it's really kind of neat. So it's the same graph that I've been showing, all the bars and the elevations of our different habitat categories. But then in this final column, we have the tidal datum information calculated from the tide gauge. And so our maximum tide, all of our habitat tidal wetland data is below that maximum tide, which makes sense. So that fits really nicely. And then the mean high water, the interface between high and low marsh, is absolutely spot on. And so, you know, we've extended that out so you can see that all of the high marsh categories fall above that and the low marsh below that. We're pretty close with mean tide level coming between mudflat and subtidal habitats, but we're quite far off on our mean low water. And that's actually to be expected because the sensor that we had on the drones that's collecting LiDAR data was a topographic sensor rather than a bathymetric sensor. So it wasn't designed to penetrate water. So we're not actually picking up all of the mudflat. So really nice interface between those two different ways of assessing tides and tide heights around Great Bay. And this is a summary. This is actually the week of high tides in Great Bay, the week that we're sitting in. And just to make the point that each high tide isn't exactly the same. There's a lot of variation. So just within this week, the lowest high tide is 8.88 feet and the highest high tide is 11.24 feet. And so there's a lot of variation, but the salt marsh vegetation responds to a longer term average of these really variable tides. So the analogy is the daily tide cycle is like the second hand on a clock, whereas the ecotone boundaries is like the hour hand. It's measuring the same thing, but over a lot longer duration. So in our context here, we're measuring elevation rather than time. So that's a point to pause if there are any questions. And if not, then I can go on to about the results or how we collected it. And if not, I can go on to some potential applications and I'll pass it to Lynn.
So if anybody has any questions, you're welcome to put them in chat or raise your hand and come off mute. If there's any questions, this is kind of a moment for any questions of clarification about what was done or what the results actually are showing. I'm not seeing any questions, Rachel, so maybe we could just keep moving in the interest of, here's one quick question from Connor. Rachel, would you expect different salt marshes to behave differently with regard to vegetation compared with inundation percentage?
I think they respond, good, Dave's come off mute.
We would expect small differences, but the whole point of this report is that the salt marshes in Great Bay are acting pretty similarly to one another, and that's what the statistics say. And I think that's the take-home message, is that in Great Bay, these data apply very well to all the salt marshes in Great Bay. However, we will talk about deviations from that when we talk about different sediment types.
Thank you, Dave, and thank you, Connor. And that's actually something that I meant to say that I didn't, is that the results that I was showing was pooled data from all 4 sites. So it really was averaging throughout the system. So as we said, we're hoping that this data might be helpful for restoration design for living shorelines and potentially adaptation projects, specifically facilitated marsh migration. There aren't any facilitated marsh migration projects that are actually taking place right now, but we're considering it, where there are opportunities to actually lower the upland that borders a marsh that might not be able to migrate because of topography. And this is where you're next to soft sediment sites like agriculture, recreational field, or something like that. And we were saying, we'd need to put in a stepwise, we'd need to lower the topography in a stepwise manner in order to account for salt marsh migration long-term into the future. And we were chatting with Dave and was saying that just putting a berm at each of the toe of each of one of these steps makes a lot of sense, because then you could wait until the water height really reaches the top of the berm and breaching it. Otherwise, you'll have trouble with invasives coming in on bare earth, which would then be killed by potential high tide flooding, extremes. So that berm approach would be, a switch from mixed upland to boom, now we're tidal again. And then, as Dave said at the beginning, salt marsh has a provides multifaceted functions to us, most particularly helping with shoreline erosion and reducing coastal flooding. But looking at restoration design and salt marshes through the eyes of a wildlife ecologist, and particularly looking at birds, one in particular that we're concerned with is the salt marsh sparrow. And that's because it's a salt marsh obligate. It only breeds in salt marshes, and just those salt marshes from southern Maine to Virginia. And its population is declining around 9% a year. And so there's a lot of efforts and research going on to try and prevent this being listed as a federally endangered species. We've worked with folk at UNH and New Hampshire Audubon and Atlantic Coast Joint Ventures to put together a statewide model for habitat prioritization for the sparrow, looking at these factors listed here. And again, top of the list, looking for larger areas of high marsh. But the sparrow is only one of 8 species of greatest conservation concern associated with salt marshes in New Hampshire. So looking at that list, we looked at Cornell's All About Birds for the habitat information. And so this is just a little snapshot from that. So sparrow, again, they're highlighting that we need these large high marsh plateaus. I looked at a different species, this marsh wren. They're actually in the cattails and even Phragmites, the taller emergent marsh. And then black ducks do occasionally nest in salt marshes, much more frequently in freshwater systems. But what the salt marsh is super important for them during the winter. They feed in the low marsh during the winter. So if I was considering those elevation designs for these species, if I was going totally for the salt marsh sparrow, it would be these high marsh elevations, 1.17 to 1.28 meters above NAVD 88, but then incorporate some higher areas if we're interested in the wren, and design for our low marsh if we're wanting to support the wintering black duck. And it's not just habitats, it's habitat features. This is a quote from our retired waterfowl biologist, Fish and Game's waterfowl biologist, pointing out that large pools can be critical to waterfowl, particularly because the deeper ones dry out later, so they wet longer, so will support fish, and which wading birds and waterfowl can feed on. And then the larger pools themselves protect waterfowl from predation. Foxes and stuff don't get out into the water. They predate when they're close to the edge. But again, circling back and acknowledging that of all these species of birds I've just been talking about, the sparrow is the only obligate species, so it's definitely the most important. But when we did statewide, not every area that jumps out as being important for sparrows. And also that you can have too much standing water on a marsh. USGS has found that the vegetated to vegetated ratio of salt marshes has a really good correlation with the net sediment budget. And when that ratio reaches, starts to become over 0.15, marsh is starting to break down and starts to flood and drown, or may vertically reduce itself, laterally reduce itself, sorry, got a little distracted. So my real key point is that there's not one single prescription for how a marsh should look like, but a diversity of habitats and habitat features supports a diversity of wildlife species and of marsh function. So looking at all of those functions in a much more holistic manner, taking off just my wildlife ecologist hat, some other things to consider when citing projects is what's in the watershed associated with a marsh. The one on the left has a lot more natural buffer, just a little bit of agriculture in it, whereas the schematic of the marsh on the right has a lot of agriculture in the surrounding upland, so potential nitrogen runoff, and a lot of developed, so potential in impervious surface runoff from that. So a project located in the marsh on the right might not might be more challenging a restoration to take place in that than one that's surrounded with a more extensive natural buffer. Then everybody's considering this, how can a marsh migrate inland naturally? If so, it can self-sustain for the longer term. If there's a barrier, the first sign that you'll see is a greater proportion of low marsh. So this is a drive-by testing of if a marsh is vulnerable. If you see it's dominated by low marsh, then you can see that it's not keeping up with sea level rise. And eventually that low marsh will be overtopped by mudflat and subtidal habitats, and the marsh will be squeezed out. So it's not just, does the marsh have a migration space? It's what's the land cover within that migration space. It's intuitive that it's a lot easier for a salt marsh to migrate into what is presently a freshwater marsh than it is to migrate into something that has a lot of impervious surface in it without a lot of other mitigation operations that would need to take place. So it becomes a lot more complex that way. So just in quick summary of my part before I kick it back to Dave, tidal wetland vegetation in Great Bay. The high marsh values range just 4.3 inches, and the high marsh growing window is just 1.7 feet. So really emphasizing why this is such a vulnerable habitat and we need to really invest and work hard to support it. And then what jumped out as well was that the low marsh has the largest growing window. And then when considering siting projects, some spatial planning consideration of the landscape big picture can be helpful. So looking at what's in the surrounding upland buffer, is it natural, built, or agricultural land cover? Can it migrate? So the project will be self-sustaining and more viable in the long term, so cost-effective as a whole. Does the land cover in the pathway support easy marsh migration, or do further modifications need to be made? So kicking that back to Dave.
Thanks, Rachel. So I think you get a pretty good idea about these plant ranges. Rachel just pointed out, there's sort of three major approaches to thinking about how to preserve salt marshes or to make them more resilient for the future. Thinking about marsh migration, thinking about living shorelines, and also, which we didn't really touch on too much, was fixing marsh hydrology due to agricultural impacts. So in the broader marsh, there's a pair of paradoxes that we have to recognize, and that is all marshes need to be flooded, and they need to be flooded with salt water that contains suspended sediments, and then they can filter those sediments out and grow, and they won't be attacked too much by invasive species if they're salty, and they'll grow well. But too much flooding can drown them, and so they have to drain. The problem is if they drain too much, if there's a whole lot of ditches in a marsh, like were created by the Civilian Conservation Corps, and before that, some of the agricultural projects, if they drain too much, the oxygen goes in the side of those ditches and it oxidizes the sediment, and the marsh falls in elevation, which makes a horrible spot for those salt marsh sparrows to breed, because it looks like Spartina patens, but it's sort of a false friend. It actually floods much more once the elevation subsides if there's too much drainage. So one of the things we have to think about is if we're trying to fix marsh hydrology and create a single path to flood and drain marshes in the tidal tide sheds, it's critical to know those elevations of the marsh plants. Next slide. Then we wanted to switch over to living shorelines a little bit. And here's a picture in Portsmouth of a granite seawall with just low marsh, just a little bit of low marsh seaward of it. And that's Marsh's feeling coastal squeeze. This is a very, very old living shoreline from 2002, where we moved some rocks around at the site to try to make a small ledge and widen that shoreline. But it shows the problem with sea level rise and granite walls, the granite seawalls. At some point, that marsh is going to just disappear. So we really have to start thinking about taking these walls away if we want the marshes to be protecting our shorelines. Because without the marshes there, that granite will be undercut by the wave action and the granite's going to fall in anyway. So the problem is, if you have a little marsh in front of a seawall and you think everything's fine because the marsh is doing such a great job protecting it from erosion. But once that marsh is gone, then you're in trouble. So we need to think about developing new techniques, better techniques to protect our shorelines. And living shorelines is one of those ways. The next slide shows just a broad range of living shorelines, from vegetation only to vegetation protected by a breakwater. And the last image was a sill. So we had a little bit of marsh with a sill. So that's one of the techniques. Other marshes might have edging. And then the two examples to the far right they're not really green infrastructure or living shorelines because there's no biological component to them. The next slide. So when considering living shorelines, this is Wagon Hill Farm in 2017, and then 2 years later, where a stone sill has been added. We also added the bases of trees in one section to see how well that worked out. You can see a couple large boulders on the surface of the marsh that those are to break up ice, because in New England we have ice damage in the winter. And then in the mid-ground, you can see a core roll. And the core was sort of the division between low marsh and high marsh. And the core roll was at a spot where there were large mature trees shading the marsh. That's one of the problems. So marshes need a lot of sunlight. The trees were shading it. With the trees and the marsh survival, we're not going to work together. So the trees were removed, and we graded that up above it so that we could have that marsh migration. So we set this up with plant species, and the next slide shows Rachel's data with the data the data we went with, or what we created before we had Rachel's data. So Rachel's data is new, from this report. So they actually match up really well. We did low marsh. We did a trial of some high marsh plants a little lower in elevation that they didn't do so well. So the high marsh is growing where it is. And then that upper edge of the high marsh, because we use sandy sediments, it drains a little bit too well, probably. If you don't use sandy sediments, the low marsh gets hammered by really low redox potential and causes loss of the low marsh. So we like sandy sediments, but not. We're kind of changing our thinking, and Rachel's data kind of fall into show us that Rachel's data, this new data that Rachel and Chris Peter and Jamie Carter put together, show us that we should be able to grow marsh at plus 1.4 feet, or almost that much, maybe 1.4546 feet above NAVD. But in this case, the core sediments won't support that. And you can see this in the image to the right. You can see a very healthy low marsh in our new low marsh, and we can see a really healthy tidal buffer zone with the shrubs. And in the middle are these are Spartina patens, which grew fabulous the first year, but then I think during the winter they got drought stressed and a lot of it died off right in the middle. some of it, they're still there, so the coverage is good. They're protecting the soil, and they're being colonized by things like Disticlus and Juncus. So in these cases, if you're doing living shorelines, I would definitely include put a lot more Disticlus and Juncus in than you might do if you were just going to do alterniflora and patents. I think dividing, having a few different species is a really good idea. I think that's it for me. So, yep, thanks. So we have time for questions. I think we left, what, 12 minutes? It's pretty good.
Yeah, nice job, you two. And thank you. That was a really clear and really thoughtful presentation. So this is a time here for questions. We'll do questions for about 10 minutes until the top of the hour. And then, like I said, there'll be an extended time if people want to stick around and just do a little more chit-chatting. And there was one interesting question that came in during your presentation. And Alex, would you mind just coming off of mute and maybe verbalizing your question? It's a nice kind of big picture, thinking about implications of all of this.
Sure. Yeah, this is Alex Levy with VHB down in Atlanta, Georgia, where we still have some prized coastal estuary marshes in this state, but something that we've run into, and I'm curious how y'all have handled it. This is much more of a administrative than a biological question. As important as putting the right species are in the right place when vying for ecological restoration, do hydrological alterations associated with the historic agricultural practices like terracing berms and canals become problematic as regulated cultural resources? And if so, how is altering these landscape features been for habitat restoration where there's a nexus to federal or funding or permits?
Wow, so that's a great question. So because they're agricultural features, they may be protected under Section 106, where you need to do archaeological work to receive federal funds to do the restoration. And we haven't run into that problem yet, but in New England, but that doesn't mean that we might not run into it in the future. That's a great question.
Not even for federal permitting?
Nope.
Huh.
No, not for federal permitting. It's just hard to see how a drainage canal would trump ecological benefits, but I could see that happening.
Alex, were you actually talking about berms, or is yours more the historic nature, more like tide gates, more built infrastructure rather than native elevation?
Anything that's been dug or constructed.
Gosh, that's most of our marshes.
That's many of ours as well. A lot of our coast was converted for rice production during colonial era.
Yep. Yes. So, my response to that is yes, if you can make them be functional rice farms, good luck. But if you can't, then you better get out of the way. But I know Section 106 doesn't deal with that. So I think the best thing to do is involve the Corps early in any project and have them be, if you can, have them be the permitting lead so that they might be able to find a path through. Wagon Hill Farm, that living shoreline did have to go through 106 because of the federal funds. And so we did the archaeology and we got the permits to do what we needed to do.
But it still wasn't a simple process, the permitting piece there. It seems like there are some trade-offs and some things to really discuss at that.
It was an extra step
stage
and an extra cost. And so it probably took 9 months, but it didn't delay the project 9 months because it was all we planned for it.
Curious if there's other folks who this presentation sparked some other kind of reflections on your own work or other applications or applications you'd like to ask about. Yeah, Maggie, do you want to come off mute and share your question?
Yeah, I just tried to start my video. Sorry, I would, but for some reason it's not working. So this is really interesting. I want to thank you for putting this on. I actually worked on the Wagon Hill project when I was in undergrad at UNH, so it's cool to see this. And I now work for a small environmental consulting company in New Hampshire and Maine, and we're kind of looking to get involved in projects like this. I'm wondering if you see anywhere that a company like mine would be able to get involved in this and where there is need.
I can share one thing, and then David will see if you agree with me. But we just kind of launched and kind of wrapped up actually a design project for living shorelines around Great Bay, just to kind of take ideas sort of through that design process, but not actually build them. And it was interesting to do that because it surfaced some of the barriers for different types of parcels of land around Great Bay for using a living shoreline approach specifically. And one specific gap we found was that really small pieces of land, right? Like a private landowner whose land abuts, an estuary. There isn't really an easy way for them to do restoration work on their property. It's hard to find the plants as a single homeowner. It's hard to do the design work. It's hard to find contractors and engineers that want to work on really tiny projects. So it strikes me that that's a little bit of that's a niche potentially. If anybody else has comments on that, David or Rachel, or even others in the Zoom.
Thank you, Lynn.
There's no other comments. There's a couple of questions. Elsa, I see your hand. I'm going to just take a couple of questions that came in through chat. Christina asks, Dave, can you expand a bit more on the best types of sediment to use with different species? For example, why was sandy soil not so good for high marsh species in the living shoreline example?
Sure. I think what happened is in two different marshes we worked in, the Spartina patens grew extremely well in the summer and then did not come back the following spring. So I think it dried out too much in the winter. So winter death is often associated with desiccation. And so a lot of the plants that aren't adapted to survive our cold winters up here die because the water film comes away from the roots, and that can happen easily when you have coarse-grained materials. And so adding finer grain. So the next project I am going to get more finer grain material and more organic material as we move up. So once we get above +1 foot mean high water, the mean high water elevation, or +1 meter, I guess, +1 meter NAVD 88, we're going to start adding some, we'll probably start with the same sediment and then add organics and finer materials to it. And so we'll probably do it in a series of sections and trenches so that we'll know which area is getting which amount of organic matter as to an experiment. And that's how I probably run it. It seems like the Disticus is less susceptible to drought desiccation in the winter than the patens, and I don't know why that is. It's just that's what I've seen.
It's great to hear the specifics of your own experience. And David also put some comments in the chat too with some specific response to that too.
I do have a seed bank question.
Yeah, want to take that one?
Would the seed bank contribute to the elevation at which you might find the plants you studied? I think the answer is a resounding yes, but very few people have really worked with using seed banks to establish plants. And our regulatory system, if you're going to work on our under regulation, in other words, for mitigation or federal money, they're going to want to see instant success. And I think it's better if we work at the speed of nature, but it's more difficult to do that and be quote unquote have the project be successful. So sometimes you can have, maybe if you have a little bit more width of variability, so the project doesn't have to have 75% plant cover, you could try seed banks. And I would use seed banks, and I think we do in many cases using different techniques. So we take jute, just widely spaced jute fabric, and use that a lot of times instead of buying the more expensive core, because volunteer groups can roll up the jute around rack that's collected on site. And so if you collect the rack in the early fall, so September, October, that rack will have a lot of seeds in it. So the rack will be seed rich. and you could roll that up into jute. And if you stake that down where you might have some erosion issues, that also could provide seeds for growing plants in the spring.
Dave, just to build up your comment about Disticlis, I think it might be because its root systems is, you know, a runner rhizome system. Because that in my diagram of trade-off of salinity and, you know, plant competition, those Disticlis is a pioneer of the high marsh because it can use that runner system, and so a plant can get into an area that's particularly saline, but it's collect water from, you know, its plants through that runner system, whereas Peyton's has much more of that matted, dense system. So that might be why it did better in the drought conditions.
So in other words, the Disticlis may be using water resources farther from where the plants are actually growing through those rhizomes. That's really
Thank you for putting that much more succinctly than I did.
Yeah, that's neat.
We're just about at the top of the hour, so I'd like to just kind of acknowledge and thank our two speakers for being here today and putting together a really thoughtful presentation. And also give folks to leave if they need to. I know this is a working day for most people. And there's a few questions here that maybe we can take from Sarah and Heather and Elsa for anybody who wants to stick around for a little bit longer. Elsa, do you have time to pop off mute and ask your question right now?
Lynn, unfortunately, I do have to run.
Okay.
Actually, my camera is over here. So the question that I wanted to ask had to do with the choosing the step height when you have the migrating high marsh and you're creating sort of that tiered scenario. I'm really curious about how you choose those elevations. And I imagine it has something to do with, you know, trying to target mid-century or late century based on what you've calculated the sea level rise to be at that location. But I'm just thinking in terms of the mosaic type of approach that we talk about and providing the potential for high marsh in between those threshold elevations where it would overtop the berm. So I think it's a longer conversation for another time, but I will say that I really appreciated this webinar and I really appreciate the report that you guys put together. This information is incredibly helpful. So if there's a possibility to follow up afterwards and to speak with David or Rachel, or, you know, send an email, I would love to be able to do that as well.
That would be
Okay.
great, because we're very much in the conceptual stage, and it sounds like we have quite a lot to learn from you as well, Elsa.
We're a small community and we're all learning from each other. So
Yes.
it was, you know, I really wanted to be a part of the design team when you guys did that design around the Great Bay, and I wasn't selected. And I can see that you guys did great work. So I'm really thankful to be able to interface with you right now.
Wonderful. Well, thank you so much, Elsa.
Yeah.
All
And that's
right,
a great
take care.
segue.
Thanks for
We'll
this.
make sure that we follow up with everybody over email and that you get access to both of the presenters' contact information too. Thanks, Elsa,
Thank
for
you.
sticking
It's
around.
helpful. Thanks, Lynn.
Okay.
Bye.
Maybe we can answer Elsa's question in the discussion, Rachel. You know, I mentioned creating a berm and then having a system where you could just take it away once the tide height was higher. But I did work with a landowner in Portsmouth where we designed a system where they could have their flowering perennials on the tops of very short little hillocks. And what that means short, I mean 6 inches higher than the areas that were going to get flooded by the spring tides. And so we designed that so the spring tides would run through these. They'd still have their wildflowers where they wanted them in their yard, but the salt would run through them, salinize the soil, and they would just get salt marsh plants for Sparrow and Disticlis in between their perennial beds. And so far that's working out for them. And it's very early days, but they're happy with the result, and we'll see what happens in the future. So maybe that's another thought in terms of thinking about ways to interlace salt marsh with upland as sea level rises on this marsh migration path.
That's a really fascinating idea, and as you say, it would be interesting to see how it evolves. And it just underscores Elsa's comment comment that we really are learning about this as a community together. So ideas shared and novel creative thinking is awesome.
Mm-hmm. And I can see there's some other questions in the chat too about the maximum slope for grading in order to support marsh migration. Very closely related, I think, to Elsa's question, but I don't know if there's any reactions to that one.
Yeah, I think the maximum slope we use is 3%, Sarah, but I really have to defer to my engineer, and I'm not an engineer. So it's like, that's out of my bailiwick. I should know what the answer is, but I don't. Sorry.
Yeah, well, we can follow up with some of these questions too.
I think one of the challenges is in created marsh systems, if you're going to have a slope of even 3%, you're going to have to think about how you're going to move stormwater through the system. Because it rains hard, you know, we have summer thunderstorms, and when it rains hard, and the water's got to go somewhere if it's not seeping into the ground. And so we really have to think about what we did was we are using small drainage paths and core logs to capture flows and deposit the sediment so the flows don't get channelized, and also to shunt flows off so that we can drain them through a swale, maybe with Spartina pectinata in the swale that's mostly fresh, and the pectinata does great, but it doesn't erode at all because the pectinata is great at stopping erosion. So I don't know if that probably doesn't answer your question, but I think we have to recognize that in created systems, we do have to account for slope and account for stormwater. It's really important.
In addition to the plants and the plant migration question. Okay.
Yep.
So Heather has a question in chat, but I think she's still in the Zoom. Heather, do you want to pop off and ask your question, or if anybody else wants to as well, take advantage of who's here with us. Heather asked kind of a thought-provoking question here about your thoughts on thin layer deposition as a restoration methodology.
Yeah, I think where it's needed, it's great if it's thin. So there's about a line somewhere between 5 and 10 centimeters depth. And if you talk about beneficial reuse, the Corps doesn't really care about 5 to 7 centimeters depth. They want to get rid of a foot of sediment, and that's not thin layer deposition. So I think thin layer deposition can be great. I haven't seen it done over large surfaces except by Mother Nature. So we had Winter Storm Grayson in January of 2019, I believe, covered acres of marsh with an average of 1 inch, so 2.5 centimeters of sediment, and it did great. And that marsh is now in an inch, and I think in the future it'll be more than that as the new plants get into that sediment and grow. An inch taller than it was. So, but small steps. So I think adding a foot of sediment is going to create big problems, and they've had those experiences in Rhode Island, and so they're working through them, and it's big challenges.
And I totally agree with that. And I just add that of our restoration practices available to us, it's can be a fairly high cost one. So it could be used in marsh that you have particular interest in or had some social value, but there are lots of other strategies, whether it's restoration or conservation, that can maintain or maximize our overall acreage of salt marsh that are cost effective. And I do see that in general, we did a nationwide study of the sort of health and resilience of marshes. And in general, New Hampshire's in reasonable good shape. So we definitely have marshes that require intervention, but it's rarer that we need to go to those like extreme cost approaches. Whereas places like, as Dave just referenced, Rhode Island, whose marshes are in a lot worse shape in terms of not keeping up with sea level rise and places in Northern California too, then I would say that that was a technique to go to more quickly than we need to with our suite of options here in our present state of marshes in New Hampshire. Just my humble opinion.
Well said.
The humble